Hello everyone. Today we'll be looking at the transformations on our trigographs. I will start with the transformation on sine graph first. Okay, whatever happens to sine graph, okay, the same thing will happen to our cosine graph. Okay, there are basically three transformations that you are going to be learning. Okay, first is something called a vertical stretch, where your graph is stretched in the vertical direction. Another one is a vertical translation, where your graph is being shifted, up or down. And lastly will be a horizontal stretch, where your graph is being stretched, horizontally in the x direction. Okay, we will learn the first one today, okay, and hopefully the next two in other lessons. But ultimately, once you know how to do each of these transformation, our final one will be combining all these three transformations into one transformation. Okay, so today we'll be focusing on vertical stretch. Okay, this is our basic sine graph, okay, where the period is 360 degrees, the amplitude is 1, the maximum point is 1, the minimum point is -1, the maximum occurs at 90 degrees and the minimum occurs at 270 degrees. Now, I am using y and x, okay, y equals to sine x. Previously, we used theta, okay, but those are just variables. We can always change our variables. So from now on, I'm going to use y equals to sine x or cosine x or tangent x, alright? These are just variables. But the x, okay, since it is inside sine, it will represent angle. So x will be in degrees. Okay. Now, we started with y equals to sine x. Alright. But the thing is, the number in front of sine x is 1, because 1 times sine x is sine x. Don't ever think that it's 0, because if it's 0, then 0 times sine x is 0. It's gone. Alright. So whenever you see y equals to sine x, the number in front of sine x is always 1. Okay, so do not forget this basic graph of sine x. We are now going to do a transformation on it. So, how does the graph look like if I were to change the 1 into some other number? Okay, basically, how does y equals to a sine x look like? I'm going to play this video. Okay, observe how the graph changes. Okay, on the screen right now is a graph of y equals to sine x, the most basic graph. Okay, you can tell from the screen, the amplitude is 1, the period is 360 degrees. Okay, let's play. Okay, I'm plotting 2 sine x. See what happens. Look at the blue curve. What has happened? Now I change to 3 sine x. See what happens? It becomes stretched in the vertical direction. Okay, even a bigger number, 10 sine x. Okay, what happens? It becomes 1.5. Okay. Alright. Now, so what have we learned? So this is the most basic, graph, y equal to sine x. Now, I'm going to show you how does 2 sine x look like. If you understood the previous video, it will look something like this. Okay, it has been stretched in the vertical direction. But this time, our maximum point is 2, and our minimum point is -2. Now notice, my maximum point still happens at 90 degrees. Okay, it still passes through 180 degrees. My minimum point is still it still occurs at 270 degrees, and the period is still 360 degrees. So only the amplitude changes, everything else remain the same. So whenever we change the number in front of sin x to any other number, only the amplitude will change, everything else remain the same. Alright? Okay, let's do another example. Let's say I want to draw y equals to 5 sin x. Now, since we know that only the amplitude change, so we just draw as per normal. Just draw a normal sine curve. Okay, the angles, remember, the angles are unchanged. So the 90 is still there, 180 is there, 270 is there, and 360 is there. But what changes? The only change is the amplitude, okay, or the maximum point, which is 5, and the minimum point, which is minus 5. That's the only change. Now, for y equal to sin x, what is the amplitude? Okay, it is 5. Period, still 360 degrees. Axis of curve, do you remember what is axis of curve? The axis of curve is a line that passes through the middle of the curve. Okay, it is still the x-axis. Alright, let me show you some more examples. Once again, this is y equal to sin x. The purple one will be y equals to 2 sin x. Okay, now what if it's something even shorter like this? Okay, this is y equals to 0.5 sin x. Okay, the maximum point still happens at 90, and the minimum point still happens at 270. Alright, okay, we've been looking at a sin x, but only when a is positive. What happens when a becomes negative? Okay, let me play these simulations. Now I'm plotting y equals to negative sin x. Look what happened. The graph is flipped. Okay, becomes upside down. Okay, so if this is our basic sine graph, if I were to draw a negative sin x, okay, the graph will be flipped upside down like that. So that's what the negative does. It flips the curve upside down. Okay, so the negative basically makes all the positive becomes negative, and makes all the negative becomes positive. Okay, so that's what the negative sign does. Okay, another example. How do we draw y equals to negative 3 sin x? Okay, first thing, notice the negative. Okay, when you see negative, you must know your graph is flipped. So you draw a flip graph first, like that. Alright, now the angles still are the same. So the 90, 180, 270 and 260 are still the same. Minimum and maximum, okay, the minimum and maximum will be negative 3 and 3. Alright, the period is still unchanged, is still 360. My axis of curve is still the x-axis. And my amplitude, now what's amplitude? If you are tempted to say it's negative 3, you are wrong. Okay, amplitude is always positive. So the amplitude is 3. So in general, for whenever you want to draw y equals to a sin x, okay, what are the properties? The amplitude will always be a. Kalau y equals to sin x, the amplitude is 1. if y equals to 2 sine x, the amplitude is 2. Okay, now why did I mention positive value? Okay, previously we did y equals to negative 3 sine x, but the amplitude is not negative 3, the amplitude is 3. This is because amplitude is a positive number, so we just take the positive value. Period is unchanged, it is still 360 degrees. Axis of curve is still the x-axis. Okay, so this is the first transformation on our trigo graphs, the vertical stretch. So y equals to a sine x, that a will cause a vertical stretch on our sine curve. Now, we've been focusing on sine curve. Will the same thing happen to cosine curve? The answer is yes. Okay? When the same transformation, when applied to cosine curve, okay, the same effect will happen. It will be stretched in the vertical direction. So let's watch this video. So this is a y equals to cosine x graph, the most basic one. See what happens when I draw y equals to 3 cosine x. It becomes stretched in the vertical direction, same like sine x. And notice the period, the angles are unchanged. Okay, 0.4 cosine x, it becomes shorter. Now let's see what happens if it's negative. Okay, before that, okay, 1.5 cosine x, also the same stretching. Okay, only the amplitude changes, everything else remain the same. Okay, now I'm going to make it negative. See what happens. The same thing, the graph is flipped upside down, just like for the sine curve. Negative 2 flipped and become more stretch. Okay, so what we did today was simply looking at y equals to a sine x or a cosine x. The effect of a in front of the sine and cosine is just to stretch the curve vertically. Alright, everything else remains the same. The period is still 360, the angles are still the same, only the amplitude changes. Alright, that's all for today.